All right, so for the lesson today, we are going to go over chapter 1.5, subtracting rational numbers. Your essential question is, how can you use what you know about subtracting integers to subtract rational numbers? The question on the left-hand margin is, how do you subtract decimals with the same signs and with different signs? So the main thing we want to know always, whenever we're dealing with decimals, whether you're adding or subtracting up, will always be to line up the decimals. Now, if we are talking about subtracting, let's remember our subtracting guidelines or rules for this chapter that we've learned, which is different signs subtract. When you subtract, you keep the sign of the bigger number. So this is something that we're going to keep practicing all school year, and something that that's going to be true from now on. So we're going to get used to it, right? The rest of your education, when you're dealing with math, you will have to deal with this rule. So here's an example. Find the difference. Write your answer as a decimal. 4.9 minus 1.6. Well, it's just a common subtracting problem, right? Like if we were to deal with money, this is $4.90. We just don't have the zero. And then you spend $1.60. How much money you have left? So 4.9 minus 1.6. We line up the decimals. Bigger number goes right on top. 9 minus 6 is 3. The decimals, we just bring it straight down. And 4 minus 1 is 3. So 3.3. Or if you were to add a 0 at the end, $3.30. How do I solve a double negative? So we've been going over this now for at least last chapter we started going over it. Remember, when there are two negatives next to each other with no numbers in between, that is a double negative. So my example is right here. There's two negatives right next to each other with no numbers in between them. So in between them, you have a parenthesis, but that's not a number. For another example right here, look, I have two negatives, but I have a number in between them. So that's not going to be a double negative, whereas right here, it is. When you have a double negative, you can connect the negatives and turn it into a plus sign. The reason being, when I have two negatives, we'll learn about this next chapter, they cancel each other out. All right. It is a multiplication rule. So this chapter is about adding and subtracting. Next chapter, I believe, will be about multiplying and dividing. So we'll go over your multiplication rules. This is a little preview. A negative multiplied by a negative gives me a positive. So a trick is you can essentially, it either turns into a positive, like so, or you can literally draw a line connecting them and make this a plus. So let's actually go ahead and do that just so you have a better visual. Once I do that, step one, connect the negatives to make it a plus. I'm going to have a negative 8 plus an 8. So negative 8 plus an 8. I just rewrote it down here, how it's now going to look like after we connect these negatives. So a negative times a negative will give me a positive. So I have two negatives here. I'm going to connect a line and make this a plus. Now I'm going to rewrite it as negative 8 plus, this is the plus I just made, the 8. A lot of times students get confused where after they make this plus, they still leave this negative. The whole purpose of connecting these is to get rid of the negative, and it's like the two negatives combined to make a plus. So now we have a negative 8 plus 8. Same signs add, different signs subtract. So this is like, if something costs $8, that's why it's a negative, and you have $8, so you buy it for $8, how much money do you have now? Well, you don't have any. right? So same signs add, different signs subtract. This is a negative. This one right here is a positive. They are different, so we subtract them. 8 minus 8 gives me a 0. The answer is 0 because the signs are different, so we subtracted. Remember from last lesson, 0 is not positive nor negative. It is just 0. If I have a number line, 0 is in the middle. So here are your positives to the right of the number line. So 3. And to the left, I have my negatives. Well, 0 is kind of like the halfway point. So 0 right here is neither positive nor negative. All right. And another way we can express this after I combine them, if it helps, I could do it like, let's see here. I have 8 negatives, so I could draw 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. Then I have 8 positives, so I can do 8 positives. 1, 2, 3, 4, 5, 6, 7, 8. Well, a positive and a negative are opposites, so they cancel out. So I could, well, this cancels this one. Every time I see a negative and a positive, I want to cancel them out, which is why I just put them one on top of the other one. And look, they all canceled out, so I can go ahead and I don't have any left, right? If you had $8 and you spend $8, you don't have any left. So that's the gist of this. Okay, let's go to some practice problems dealing with not only the difference, but also when we have fractions. And then that will be it for the lesson. So let's go ahead and try solving these. Okay, so for the first one, I have a 12 minus a negative 3. We're going to go over 2 ways that we can solve this, right? One with keep, change, which we learned last chapter, or sorry, not last chapter, last section, or utilizing our shortcut. So I have 2 negatives right next to each other without any numbers in between. We see a parenthesis in the middle, but that's not a number. So that means a negative times a negative gives me a positive. Again, we'll talk about that next chapter. For now, I'm going to connect them and make this a plus. Now I'm going to rewrite what I have. 12 plus 3. Well, what's 12 plus 3? 12, 13, 14, 15. So my answer is 15. Right? It's as simple as that. Let's try it utilizing keep, change, which we talked about last section. And remember, keep, change can only be done when you see a minus sign in between the 2 numbers when it is a subtraction problem. So it's going to be, I drew my arrows. There's keep, change. Okay, CC. 12. I'm going to keep this the same. The negative, I'm going to change that to its opposite, which is a positive. And the negative 3, I'm going to change that to a positive 3. Well, look what I have now. What I had, the same thing I had when I combined these. So this was just a shortcut when I can combine them and make it a plus. 12 plus 3, 15. Awesome. All right, now let's do the same thing for 2. So just find the difference, write your answer as a fraction in simplest form. So whatever fraction we get, we're going to have to simplify it. Big ideas always want everything in simplest form. So again, 2 negatives with no number in between. It's just a parenthesis. So let's go ahead and try our shortcut where we're going to connect them because two negatives make a positive and make a plus. I'm going to rewrite these just so we understand what we have, because sometimes students get confused and they leave a negative there. Well, when I connected them, the negatives are gone. When we're adding fractions, remember the denominators have to be the same. In this case, they are. So it's going to stay the same. And I can add the numerators across. So 5 plus 7 gives me 12. Now, 12 eighths. I don't expect you to turn this into a mixed number. It's fine as an improper fraction, but it wants it in simplest form. So we're going to have to simplify this. And hopefully this is a review from previous grade. So I'm going to have to take this 12 and this 8, and I have to figure out what I can divide them both by. Well, they're even numbers, so any even number can be divided by 2, or they can be divided by their GCF, which stands for their greatest common factor. So if I was to make a factor list of 12 and 8, you can also make factor trees. Let's try the tree instead. So I'm going to go ahead and erase this over here so I have room for my tree. Okay, so let's do one for 12. What are two things that multiply to 12? Well, let's say 2 and 6. Okay, 2 is in simplest as I can go now. I mean, I guess if you wanted, you can do 1 times 2. And whenever you see the 1, this tells you to stop. This, I could do 3 times 2. And if you wanted to, you can do 1 times 3 and 1 times 2. But for the most part, this is done. So 3 times 2 times 2. Okay, well, now I can do the same thing for 8. 8 I know is 4 times 2. And then 2 times 2. Well, I see a pair of 2's down here. So I know I can divide it by 2. Or go ahead and erase this one right here. I know 2 times 2 equals 4. And I have a 4 right here. So I could divide the top and bottom by 4. And this would give me 12 divided by 4 is 3 over 8 divided by 4 is 2. So my answer would be 3 halves. If, let's say, you don't know how to make a factor tree, hopefully you know that these numbers are even. So we can divide them by 2. 12 cut in half is 6. 8 cut in half is 4. The problem with 6/4 is that it is still not in simplest form. So we would have to divide it by 2 again. Divide this by 2 because it's even numbers. And this would give us 3 halves. When you try entering a number into big ideas, it generally wants everything in simplest form. So you're going to have to be careful and make sure we are practicing our simple dividing and turning this into simplest form. The other thing we could do if we don't use our shortcut is you can use KCC, right? So you can use 1, 2, 3. And remember, I'm making these arrows because I have 3 different things here. I have the 5/8, I have my negative, and then I have the negative 7/8. And this would be, I can do this because I have a minus right here. You only use keep, change when it's a subtraction in the middle. Keep, change. Keep the 5/8 the same. Change negative to a positive, and then change my negative to a positive, which was the same as the shortcut, connecting them and making it a plus. Denominator stays the same because the same denominator means we can add. 5 plus 7 is 12. And then it wants it in simplest form. So we go ahead and divide the top and bottom by 4. So this would be 3 over 2. If you have any questions, go ahead and just let me know. And you can rewind this, right, if you need to watch it again. In terms of the lesson, that's it for today's lesson. We're now going to try big ideas, 1.5, right, problems. Right, let me know if we need some help.